possible continuous chain of the carbon atoms including functional group and multiple bond is taken as parent chain. Their position is indicated separately and prefix such as di, tri, tetra are used. The functional group with a higher priority in the sequence given below termed as the principal functional group. Hello students, I am Ramya, lecturer in chemistry from Vidhyaashram, the Temple of Excellence, Mysuru. In the previous session, we were discussed about introduction, tetravalence of carbon, shapes of organic compounds, hybridization and bond characteristics, structural representation of organic compounds, classification of organic compounds, homologous series, nomenclature of organic compounds. In this session, we were going to discuss about IUPAC nomenclature of alkanes, straight chain hydrocarbons, rules for nomenclature for branched chains of alkanes, naming of cyclic compounds, naming of organic compounds containing functional groups, naming of compounds with the polyfunctional groups, nomenclature of substituent benzene compounds, arrangement of prefix, root word and suffix. Order of IUPAC name is prefix, root word, primary suffix, secondary suffix. For example, in this compound, prefix is bromo, root word is prop. Why it is prop? So, because of the 1, 2, 3 presence of 3 carbon, we call it as it is prop. Primary suffix ANE, that means alkane. This is alkane compound because of the presence of single bond within the carbon. IUPAC name is bromopropane. That is bromo because of the presence of Br group to the first carbon of the compound. We call it as bromo. Prop means presence of 3 carbon. ANE means alkane compound due to the presence of carbon-carbon single bond. In the next example, presence of OH group to the first carbon of the compound, that is root word but. Why it is but? Because of the presence of 4 carbon. Primary suffix ANE because of the presence of single bond within the carbon. Secondary suffix is OL, that is butanol. Because of the presence of 4 carbon, we call it as but. Presence of OH group, the suffix we are going to use OL. Rule, naming of alkanes. It's a rule, that is first we are going to consider the root word, then primary suffix. For example, presence of 1 carbon, it is methane, 2 carbon ethane, presence of 3 carbon propane, 4 carbon butane, 5 carbon pentane, 6 carbon hexane, 7 carbon heptane, 8 carbon octane, 9 carbon nonane, 10 carbon decane. Rules for naming branched alkanes, that is longest chain rule. The longest possible continuous chain of the carbon atoms including functional group and multiple bond is taken as parent chain. For example, if we consider this compound, here the longest chain is 1, 2, 3, 4 carbon, not 1, 2, 3 carbon. So, this is the longest chain of this compound. In this compound, we have 4 carbon group. That's why we considered but. Presence of single bond within the carbon, take it as ANE, that is alkane compound. The compound is butane. Here the longest chain is hex because of the presence of 6 carbon. 1, 2, 3, 4, 5, 6. This is the 6 carbon compound with a single bond. We call it as hexane. The numbering in done is such a way that branched carbon atoms get lowest possible number. In the case of unsaturated hydrocarbons, atom involved in double or triple bond should get the lowest possible number, that is 2,2-trimethyl pentane. Why it is 2,2-trimethyl pentane? Because of the at the carbon number 2 we have 2 methyl group. At the carbon number 4 we have 1 methyl group. Parent chain having 5 carbon atom, so that carbon number 2 having 2 methyl group 2, 2, carbon number 4 having 1 methyl group 2, 2, 4. Trimethyl, presence of 3 methyl group, we could taken as trimethyl. Presence of 5 carbon taken as pentane. So in this example 1, 2, 3, 3, 4. At the carbon number 3 we have methyl group, that is 3 methyl. We have 4 carbon atom. We take it as but. At the carbon number 1 we have double bond, that is taken as ENE, that is alkene compound, 3 methyl but 1 ene. Because of the presence of double bond at the carbon number 1 taken as ENE suffix. When the alkane group in compound attached to the branch, then it is prefixed to the name of the parent alkane and the position of the substituent is indicated by appropriate number. If different alkyl groups are present, are named in alphabetical order. In this example 1, 2, 3, 4, 5, 6. 6 carbon is the longest chain, that is hex. We have 2 different substituents, that is ethyl group and methyl group. At the carbon number 3 we have ethyl group. At the carbon number 4 we have methyl group. One which sounds fast alphabetically, which is taken as fast, that is 3 ethyl. At the carbon number 3 we have ethyl group, we taken as 3 ethyl. At the carbon number 4 we have methyl group, that is 4 methyl. Hexane, because of the presence of 6 carbon, it is taken as hexane. In case there are 2 or more similar substituents attached to the parent chain, their position is indicated separately and prefix such as di, tri, tetra are used. In this example, we have similar substituent at different carbon, that is 2, 3, 5 methyl groups are present. We call it as 2, 3, 5 trimethyl hexane because of the presence of 6 carbon. If identical groups are present in the same carbon atom, then the locant number is repeated. If 2 methyl group present in the same carbon, we can take as 2,2-dimethyl pentane because of the presence of 5 carbon. When 2 substituents are found in equivalent position, the lower member is given one coming first alphabetically for order. For example, following compound is named as 3-ethyl 6-methyl octane. For example, At the carbon number 3, we have ethyl group. At the carbon number 6, we have methyl group. Among ethyl and methyl, ethyl comes first because it sounds alphabetically fast, so that the name as 3-ethyl 6-methyl octane, not 6-ethyl 3-methyl octane. Naming the complex alkyl substituents. If the substituent on the parent chain itself has a branched chain, then it is named as substituent alkyl group inside the bracket in such a way that the carbon atom directly attached to the parent is assigned number. That is, so if we consider this is a branched chain which is attached to the carbon number 5. So this branch also having another branch, we can take it as inside the bracket at the carbon number 5, 2, 2, 1, 2, 3, 2, 2 dimethyl propyl. Why it is propyl? Because of the presence of 3 carbon. Propyl nanane, because of the presence of 9 carbon, this compound considered as nanane. Naming of cyclic compounds. Cyclic compounds are named by adding prefix cyclo, name of the alkane having same number of carbon as the in the ring. Here presence of 3 carbon, we call it as cyclopropane. Presence of 4 carbon, we call it as cyclobutane. Presence of 5 carbon, we call it as cyclopentane. Presence of 6 carbon, we call it as cyclohexane. Here we have a substituent at the carbon number 1 and carbon number 2, that is 1,2-dimethyl cyclohexane. Because of the presence of closed ring, we call it as cyclo group. Here 1-ethyl 3-methyl cyclopentane. This is ethyl group. This contains CH3 and CH2. This is ethyl group and this is CH3 group at the carbon number 3. So that 1-ethyl 3-methyl cyclopentane. Here 1,1-dimethyl 3-propyl cyclobutane because of the presence of 4 carbon. In the side chain contains number of carbon atoms, those in the cyclic ring, then the compound considered as a derivative of alkane and the ring considered as substituent. Here 1 cyclo, at the carbon number 1 we have a cyclo group. Butyl, we have 4 carbon number cyclic group, and pentane is correct because here we have to consider the longest chain rule, that is carbon number 5, not carbon number 4. 1-pentyl cyclobutane is incorrect answer. So here 2-cyclopropyl butane, at the carbon number 2 we have a cyclopropyl group and we have carbon number 4, that is butyl 2-cyclopropyl butane. Naming of organic compounds containing functional group, that is the parent chain is the one which has functional group directly attached to it. The numbering should be done in such a way that the carbon linked to the functional group gets lowest number. When the functional group itself contains carbon atom, then the carbon atom is assigned the number 1, that is propanol. This is propan-2-ol. At the carbon number 1 we have OH group, at the carbon number 2 we have OH group. So here propan-1-ol or propanol, here propan-2-ol or isopropanol. Naming of compounds with the polyfunctional group. If there in more than one functional group present in a compound, then one of the functional group is chosen the secondary prefix and the remaining functional group are treated as substituent, that is subcoordinate functional group. The functional group with a higher priority in the sequence given below termed as the principal functional group. So this is the priority of the functional groups. So if we have carboxylic acid more priority than alkyl group, these are all the order of priority in the functional group. Naming of compounds with polyfunctional group. So we have a functional group with prefix and suffix name. So if carboxylic acid present in the compound, prefix carboxy group, suffix oic acid, this is carbamyl, amide, this is formyl or aldehyde, that is al, this is cyano or suffix nitrile, this is oxo or suffix one, that is ketone, this is hydroxy or suffix ol, this is amino or this is amine as a suffix. In carbon-carbon double bond we taken as suffix ene, that is alkene compound, and carbon-carbon triple bond the suffix taken as yne or alkane compound. So X is a halo group, NO2 is a nitro group, OR is the alkoxy group, R is the alkyl group, SO3H is the sulfo group or sulfonic acid, COX is the halocarboxyl or oil halide, COOR is the alkyl carbonyl or O8. Name nomenclature of substituents benzene compounds. Benzene is a 6-membered cyclic compounds with alternative single and double bonds. It represents any one of the following ways. Why it is? Because of the presence of pi electron inside the benzene ring, which is delocalized in the ring, and it can be represented as follows. Because of a special property, what we call it as resonance property. So this structure proposed by Kekulé. So it can call it as Kekulé structure of benzene. Naming of monosubstituent benzene. It's derived by adding the name of the substituent with the word benzene. The substituent plus benzene, substituted benzene. So if we have methyl group is substituted with the benzene, we call it as methyl benzene. If it has bromo present in the benzene ring, we call it as bromobenzene. If it is nitro group present in the benzene ring, we call it as nitrobenzene. Or this is methoxy group attached to the benzene ring, we call it as methoxybenzene. Special name, some monosubstituent benzene compounds. So this is structural formula, that is methyl benzene. Special name is toluene. This is amine attached to the benzene, we call it as benzamide. We call another name aniline. And this is OH group attached to the benzene, hydroxybenzene, or special name what we call it as phenol. And aldehyde group present with the benzene, benzene carbaldehyde, special name we call it as benzaldehyde. Carboxylic group attached to the benzene ring, benzene carboxylic acid, special name benzoic acid. Methoxy group attached to the benzene, we call it as methoxybenzene, special name anisole. If the functional group is attached to the carbon chain connected to the benzene ring, then benzene ring is considered as substituted and the prefix before the root word is phenol. So, if any substituted benzene ring attached to the compound, we call it as phenyl group. This is 3-phenyl propanol. Al means presence of the aldehyde group. At the carbon number 3, we have phenyl group. So, here at the carbon number 1, we have chloro, that is 1-chloro, 2-phenyl ethane. This is 1-chloro, 2-phenyl ethane. Naming of disubstituted benzene. If the substituted are the same, in such case, the relative position of the substituent must be indicated by adding the symbol 1, 2 or M, 1, 3 or V, 1, 4, that is ortho 1, 2, meta 1, 3 or para 1, 4. This is ortho position 2 and 6 and this is meta position 3 and 5. This is para position 4. In the tribal system of the nomenclature, the terms ortho, meta and para are used to prefix to indicate the relative position of 1, 2, 1, 3 and 1, 4 respectively. For example, we have 2-chloro substituted attached to the benzene, that is 1, 2, 1,2-dichlorobenzene or ortho-dichlorobenzene. This is a position of ortho, and here 1,3-dinitrobenzene or meta-dinitrobenzene. This is the position of meta. So, it is called it as meta-dinitrobenzene. If two substituents are different, the substituents are written in the alphabetical order. We have two different substituents. One is iodo and another one is bromo. 1-bromo 4-iodobenzene because of the presence of iodo at the carbon number 1 and bromo at the carbon number 4. That is para-bromido-benzene. Here 1-chloro 3-nitrobenzene. Metachloronitrobenzene. Here 3,4 dimethylphenol. 1, 2, 3, 4. 3,4 dimethyl. This compound we call it as phenol. If there are more than 2 substituents, that is 1-bromo 3-chloro 2-methylbenzene, 1-bromo 2-methyl 3-chloro 2-methylbenzene. So, why chloro comes first? Because of the alphabetical order. After B, C is considered as next alphabet, that is chloro compound. 2-methyl at the carbon number 2 we have methyl group. So, here 4-chloro 3-nitro and benzoic acid. This portion what we call it as benzoic acid. The carbon atom to which carboxylic group is present is attached to the lowest priority. Write the IUPAC name for the following. So, here presence of 4 carbon, that is butane. At the carbon number 2 we have a OH group 2-ol, that is here presence of ethyl group at the carbon number 3, that is 3-ethyl, presence of 4 carbon, that is butane. At the carbon number 2 we have a ketonic group, that is 2-one, 2-one. 3-ethyl butane 2-one. 1-bromo 3-chloro cyclohexane 1, 2, 3 1 bromo, 3 chloro, cyclo because of the presence of ring, hexane presence of the 6 carbon, that is cyclohexane. Here methoxybenzene or anisole. This what we call it as methoxy group attached to the benzene, that is in the special name we call it as anisole. In the next session we are going to discuss about isomerism, fundamental concepts of organic reaction mechanism. Thank you.